Hello everyone, welcome back to our Automation Rocketship channel. Here, our crew is back with another amazing episode, and this time, one of our crew members, Pradeep Shukla, has won an award for a wonderful use case that he presented during the AI Summit. So today, Pradeep is going to walk us through his use case and share all the details about his wonderful use case. Off to you, Pradeep.
Hey, thank you, Priyan. We, I'm glad to be back here with the crew, and uh, not to mention this crew is never complete without Andy, right? So welcome to this episode, Andy.
No problem. Thank you, guys. I know I'm very excited to learn about this, Pradeep, because we all watched the announcement of the award being given to you as a part of this AI solutions that you presented. So I am sure the community would like to know more about what that is, and and it would be extremely beneficial and probably inspiring for people to go about exploring how to build their own solutions using the UiPath technology stack. So, without further ado, take it away, my friend.
Yeah, all right. So yeah, thanks for that, and I was really happy and excited to see that come out. I was actually when I submitted this use case, I was not sure that this would be something that would really be appreciated and adjudged as one of the top most use cases out there. So this is the use case that I submitted as part of the AI challenge for AI Summit 2023. It's about efficient product sequencing recommendation model. So it's mouthful, isn't it? But in a way, if you look at it, this is something that is being used by e-commerce platforms across the world. Whether you can think about any e-commerce platform, if you will, whether it's Amazon, eBay, Flipkart, or uh, Byju's, or any other platform. If you go, there is some sort of a recommendation model each of these uh, platforms adopt and deploy. So what we are talking about here, so let's talk about, I'll go over these individual sections, briefly explain what's out here, and then we'll go into details of how the solution came into fruition. So the challenge was primarily for an e-commerce platform. Primarily, if you see, when you have multiple SKUs, and any e-commerce platform has hundreds and hundreds of SKUs. So SKUs means a product, right? So that's SKUs is more of a business term that is being used. So for each product under a particular category, you have multiple hundreds of products in them, and every day when customers are browsing your platform, they are going through those products. uh, the what is the biggest driver for an e-commerce platform? I mean, the end goal is to eventually customers to buy those products and also repeat those purchases, right? As often as it is possible. So obviously, turning a product into a final as a paid product or as a sold product is what the target is. And how we can influence the consumer behavior or consumer purchasing pattern is what is the goal for having a recommendation model set up for an e-commerce platform. So we
So,
all are.
Pradeep, would you say that like this is basically like mainly used by people like me who obviously, like keep adding things to the cart? So this is the reason the recommendation models are the reason behind like, me going there just to buy one thing and I might end up with like, five different things because I see the recommendation and the reviews are good.
Right. So yeah, so it influence everyday person who is visiting or any of these product websites for purchases. And believe me, if you think about it, this kind of recommendation setup is not just for e-commerce platforms, right? If you go to a brick and mortar store, you will see when you are actually standing at the checkout line, there are a ton of products out there right in front of your eyes, which may or may not have anything to do whatever you have went there to buy. But since it's kind of, in a way, the store recommends you that, see, these are also the things that you can buy here. So eventually what happens, if that something catches your eye, you'll pick it up while you're still standing on that checkout line. So the e-commerce platform is just kind of a virtual form of that, right? So by the time when you're searching for a product, you will be given recommendation that something similar to this is already available here, that that may have a competitive pricing, or that may have a, a better review, or that may have a better color combination. If you're buying an apparel or clothing, right, you may see a better color pattern on a something similar that is recommended to you, and maybe you'll also add that to your cart, and you go and obviously you end up purchasing both of them. So that's why recommendation models are very important and very core to the business of any of these e-commerce platforms. And if I go uh, a little bit of history of it, right? So the whole recommendation model, at least in the digital world, is actually pioneered by Netflix. So back in the days when Netflix was still a small startup, and they were sending DVDs and movie CDs, right, through mail. If you remember, they used to when you sign up to their platform, to Netflix.com, they used to ask you ton of questions, almost like 2 pages, 2 to 3 pages of questions that you have to answer, like what kind of movies you like, what are your favorite actors, or select 5 favorite actors, select 5 directors, select 5 movie genres, something on those lines, right? So that used to help them build kind of a repository for a particular user so that they can suggest them what other movies they may be interested. So that's kind of like very basic building block of recommendation engine. And from there on, if you look at today's platforms, again, whether it's Netflix, Hulu, if you go there, you only sign in and you just have to just provide like 3 genres that you may be interested in. And that's just to start with. And eventually, as you keep purchasing movies, or you keep watching more movies, eventually the recommendation system learns from that behavior and be able to provide you much more accurate recommendation for the next movie that you may be interested in. So that's a little bit of history how the whole recommendation thing came into picture. It started from there, but now if you see in any digital platform, you will see some kind of recommendation engine working behind the scene. Even there are small companies that are just focused on building recommendation solutions. You can just buy their recommendation solution and add the code snippet on your website, and it can suggest up to a certain extent. However, it's not that efficient, but at least it can still get you moving in that direction. So let's talk about. So we talked about the challenge. Obviously, how the challenge is how to increase sales, right? How to get a product that has been added into a cart turn into a purchased product, because a lot of times me and you all we have done that. We may have added something in cart but never bought it. So that's another challenge, right? So let's talk about the solution, what we built for this particular use case. So there are 2 stages for any e-commerce platform when we get in. So if we go in Amazon.com, for example, everyone has used that some or the other time, right? So there are 2 stages to it. The first stage is you get into the platform, you get into the website, and you search for a product. So let's say I'm searching for a t-shirt, right? So when I search for that particular t-shirt, I may have provided some other parameters, like I want a long sleeve t-shirt, a round neck t-shirt, something on those lines, right? I want a small or medium sized t-shirt. So the first search result that we get lists out all the t-shirts matching to your search criteria. And what you'll observe from top to down is that you may see products that have the highest rating to start with, something around 4.5, 4.6 out of 5. So that's one set of result that you get on your page. The second set of results would be the sponsored products, but that's not part of today's discussion, but we can definitely come out on that too and talk about that, how that gets added to that list itself. But the second set is sponsored products, and then you'll see the most favored products, like for specifically for Amazon, right? So if you search for Amazon, Amazon also provides the Amazon Basics and some of their own product categories. So they suggest that. But in general, what happens, you actually see a search result that is driven through the product popularity or the rating. So once you have searched that, the next step or next step of recommendation that you get when you select one of those products and you select that particular item, go back to the product page, that's where you start seeing other recommendation that users who have bought this particular t-shirt have bought these three other things, and then those could be a t-shirt, or those could be pair of jeans, or can be anything else, or can be any other accessory for that matter. So there are two different applications for this recommendation engine, and that's what the solution talks about, that we built two machine learning models based on supervised regression model. If we talk about what is the regression model, is the regression model is a predictive modeling concept, which is called as regression model, where we can provide a prediction with the data points that we have available. And now we can get into different type of regression models, whether it's a linear or supervised, unsupervised. There are various different branches out of it. Supervised, primarily, what does that mean? That we have the data for it, that the data that we are using to generate that prediction. So that's why it's more of a supervised model that we are going to use here. And since our use case had a very interesting, because this is a e-commerce website, things change, right? So there are changes in the purchasing pattern with over time. There are changes in terms of who the users are who are visiting that platform, uh, whether it's from demographic perspective, if you look at, and that also drives is different from one product category to another product category, whether someone is looking for certain set of products, are they also at the same time searching for altogether different products? So that kind of convolutes data over time, and it's a huge data. I talked about briefly that we had 1.5 million transaction data. That's what we use to train this whole model, piece by piece. And we broke down individual features, and once we tested started training the model, we also had a challenge to trim down the features, because we didn't want to convolute the data with a lot of unnecessary noise in it. So there was a lot of data cleaning activities that had to go through to test out uh, if a certain set of feature actually impacts the model, or they are redundant information, we can just take them out. So that's the very high level solution overview. In terms of implementation, we did implement this on UiPath AI Center with a retrainable model. Like I mentioned here, this is kind of a e-commerce website. So what we did, we actually retrained model every 7 days in order to suggest the next product item. After one product is searched, then how do you come up with the next product suggestion for the user to make sure that they are getting the product the way they are looking for, not the way it's just fed into a system. And that actually drove revenues comparatively uh, much better than what they already had in place. We saw not just improvement in terms of revenue, what they got, but also customer retention, repeat customers. We also found that customers were spending more time on the platform. So all those are some of the byproducts of having a recommendation engine, because that keeps your users engaged with your application, with your platform. So that, and the more time they spend, obviously that results into more items getting added to the cart and eventual sale of a product. So there are three primary type of recommendation models that are used in industry. First is ratings and popularity based, which is something straightforward as if you have 100 SKUs or 100 items that you're selling on your website, how many ratings out of 5 or out of 10, whatever your rating criteria is, if you see those stars for every product that you purchase or buy, or sometimes those products, the sellers of those products, they reach out through email or other marketing campaign for you to rate their products, right? So that's how they get the rating captured for each of the product. And the recommendation model is as straightforward as just listing out the top rated products in a certain category. So if you go and search for a pair of jeans, you may see Levi's jeans or some other branded jeans coming as top because they may have the best rating, right? So they are the most popular ones, and that's how you see the whole list of products out there. So it's straightforward to implement. It's if you do not have any other recommendation model on your system, I think that is the way to start with, right? Even if you don't build any complex model, you can straightforward build that out. The second is content filtering. Content filtering is where we actually look into the individual properties of a content. And that content, so right now on a e-commerce site, who is content? So content is obviously your products and your consumers, right? So both are your products. So you look at their properties, right? So you look for product properties, whether it's a name of the product, what category this product belongs to, what different size that product is available. If it's a t-shirt, then you can look at small, medium, large sizes, colors, all those features, all those properties become a parameter for you uh, to play around and to find out which product or which color, which pattern uh, gets the most sale, has the best rating out there from the customer. And similarly, you look at your consumers. So when you look at your consumers, you look at what what is their gender. They have created your profile, so you have that information in a way, right? Whether they are male, female, elderly, what is their age group, um, what is their background, because we provide a lot of information knowingly or unknowingly whenever we sign up for any product platform, right? On any e-commerce platform. So they can use that information to build a very uh, strong database or information about you, that okay, if a particular product or a particular model of jeans, so let's say a slim fit jeans is very popular between age group 15 to 25, right? But slim fit jeans may not be very popular in the age range between 30 to 40, right? There may be more preference towards relaxed fit or a boot cut or any other model, any other design, any other product type, right? So that kind of modeling can be built through content filtering. So you have data available from product side, you have data available from the consumer side, and then what you do actually, it's a matrix. So if you go back, what we built, very basic understanding of matrix back in the days of uh, high school, right? So you build a Cartesian product, and then you find out what is the most efficient or what is the uh, best product in that Cartesian product that you can recommend to your consumer. So that's what is content filtering is. Next is collaborative. So collaborative is, and this collaborative design actually model came out in 2005. So there was a research paper submitted on this, how we can build. Prior to that, we usually looked at these two recommendation models. Collaborative was the one that's kind of that changed the whole game, right? Rather than looking at so many parameters from product side or from your consumer side. See, believe me, when you're looking at all these different permutation and combinations and putting them together to make an intelligent prediction, it becomes mind-boggling the amount of data that you have, right? And then you kind of get confused at what am I doing here, right? So it becomes very challenging. And that's where collaborative model really helped, because what collaborative model is, it does not look at individual features, but it's trying to build a relationship between the consumers and uh, their purchasing pattern. So here we are talking about e-commerce, so we are going to talk about their purchasing pattern. So what does that mean? That if a consumer is there and he likes to buy three things, right? So we'll just take a simple example over here. So let's say these are my products, three different products, and these are my three consumers. Let me take this off here. So what happens that customer one likes the product one, he bought the product one, product two, and product three, and he gave a certain set of ratings. And these are just arbitrary numbers. Right now, I'm just explaining it from understanding per se how that logic works out. Similarly, for customer two, he did buy these three products. He may have given different set of ratings. But the key point is that all three of these customers have bought these three products. Okay, rating is the secondary information. The primary information is obviously that these customers liked these products. That's why they bought these products. Well, they may have not liked the product, but they bought these products, right? Because like, dislike is determined by the rating over here. All right. So now, since through relation, now we know that these three customers like these three products are then under a certain product category, right? So if a new customer comes in C4 and he's trying to search something in the same product category, our recommendation model knows that there is a set of people who like the same set of products from our website. So there is a high probability this new customer who is also looking for a product in the same category would be interested in these products too. And that's where it will pull out. So that's the first level of filtering or prediction, that you have a matching customer and you can suggest him these three products, right? And now you have the second level of decision that you have to make, which one you are going to suggest, whether you are going to suggest P1, P2, or P3. And that's where your rating comes in, right? So you can use a formula, whether you use average, mean, median, whichever you want to use. You can use a standard formula across the rating, and then based on that, you can have the second set of prediction where you recommend product P1, P2, or P3. So that's a very high level design. We have a very limited set of product set and limited set of customer set that we are looking at. One of the most interesting challenges that we'll face here is that not every customer who purchases a product, they leave a feedback or they leave a rating. So that's another missing area that you have to fill in. And not necessarily every customer who leaves a rating does that consistently over time. So he may just have left rating for one product or maybe set of 5 or 10 products, but he may have bought hundreds of products. So we have to look at data from all different aspects to make sure how we pick the the data set that can give us realistic results. And that's where a lot of uh, trials happen, where we have to look at different combinations. So for example, if you're looking for customer what we did, we only took customers who have actually left above, who have left a rating for more than 100 products. So we only took those customers as our sample data, right? And similarly, the products that we picked for our evaluation, we took those products that were sold more than X number of times. So we are trying to find a pattern within pattern to make sure the data that is derived from it is meaningful.
I see, Pradeep, going by what you just said, a couple of challenges that you already pointed out that stuck in my head is one is the what you might call the product parameters that you choose, right? If you are starting with products that have got like 30 parameters, then you need to come up with some kind of way to limit them, right? I mean, that's the first challenge. And when you spoke about leaving ratings or feedback, uh, other than the challenges that or other than the scenarios that you described, you also have the situation where people would leave what you call delayed ratings and feedbacks. They might have bought something in January, use it for 6 months, and then they say, okay, I'm either satisfied with this or I'm not. And
Yeah.
based on that, they would leave a feedback, right? Or someone would come and give an early feedback, then they would be not happy with the product. And 3 months later, they'll come back and amend the rating and say, okay, this was 4 star. Now this is 1.5 star. And I've updated my rating for this reason. I think it's very challenging at any one point for the model to stay static, right? I mean, it has to
Right.
keep evolving.
Right. So it's never about that we have a final model and then we can just go with it. And
Yeah.
that's why what we did as part, I think I briefly mentioned in that use case also, we kept, I think, running this every week. Yeah, frequency is X number of days. So essentially what we did, we ran this whole model every 7 days
Right.
to start with, and then later on we slowly went to 15 days and then for a month, so that we have built a good data set behind it, and we are getting consistent prediction, because overtraining is also another problem, right?
Yeah.
So we had to evaluate that, okay, whatever outcome we are getting the next time, we are not, even though it may be a slight improvement, but we are not compromising performance and other things.
Right.
So
Right.
we had to look at those aspects too. So now that I've briefly touched upon different type of recommendation models, what can be used, which are used in market today, and one thing I skipped. So out of these three, so these three are kind of, you can call them the basic recommendation models. There is a fourth one, which is we call a hybrid model, which can be a combination of any of these three, uh, whichever way it can be, and these are implemented by every organization has their own way of implementing it. So that's up to them. There are few other models out there. There are small startups, and there are a few libraries also. There is a light uh, LFM Python library as well that can be used to build the first version of your model, and then you can customize it. It's a Python library, so you can definitely work with that. And so here, let's look at this diagram. So this diagram talks about, we have a data source, which is where we have the actual 1.5 million data set that we picked up for our model training purposes. Out of that, we have the product data analyzer, which actually picked up the set of products that we are going to use to build our model. This is where I talked about that we only picked up certain products that have been sold X number of times, so that we have a good concrete uh, data to work with. Similarly, customer behavior analyzer, where we talked about uh, what customers we want to pick up, the customers who have given the most rating, most consistent rating. Those are the customers, and their buying pattern was picked up as a data set for customers, which is fed into the model. The model that we built was built with Python and its libraries, and that is deployed on AI Center as a retrainable model. Um, Once the model is set up, we are able to consume that model through our website, through an API. And like I mentioned, the model is updated every 7 days, but we can run this anytime, any point of time to resequence the products on the e-commerce website itself. And the we always kept the retraining up to 2 weeks level, and then before before it's released in production, we had multiple set of tests, test iterations that we conducted, so that we are not getting into that overtraining bias, um, to impact the whole performance of the product. But yeah, all in all, this use case was very interesting and very challenging. Some of the data scientists that I was working with, we had a lot of long conversations, and we had to make choices going back and forth to come up with the set of parameters. What should be that threshold that we should use for identifying products, consumers, and uh, their Cartesian product, if you will, in a very straight term. Uh, the cross section of it can provide you the best recommendation.
And
So
Pradeep,
that's
you did mention like two models that were built with your team, right? So with that one, and I believe you didn't use any of these out of the box UiPath models because this is a very unique sequence. So I believe you guys built like a custom ML model for this case, right?
right. So in UiPath out of the box model mostly are NLP based, which are primarily working on text. I don't think there is a recommendation model out of the box recommendation model out of there. There are few on the, I believe, in the marketplace, but that is what my next step is primarily, to build a marketplace component that can be leveraged by the community and be available for them to leverage it. And once I have the solution, the marketplace component in place, I will release the code also on GitHub so everyone can take a look at it and provide their comments and feedback. So yeah, that's what the plan is. I was super stoked to find that this got selected, and it's very interesting working with that so much of data. Before that also I had built few recommendation models, but more those were primarily just kind of a proof of concept, uh, if you will, but not with the production data. So that's was really interesting to go through this exercise.
Yeah, it was really nice to, get to know like the actual mind behind, like it felt like, getting to know the idea behind Netflix itself, like, how these suggestions are made. So I think it will make anybody who's listening more relatable to understand like how they can, understand this on a from their day-to-day life scenarios that they are seeing. So I think it's a really cool idea what you just proposed, like, to put it in the marketplace. I'm really curious to see like how people are gonna take it and shape it into like, how they're gonna apply it into their scenarios. And if anybody who's, like applying this, please come back and comment on this video, like what's your take and like how will you apply this specific recommendation models. We'll be happy to like, learn from each of each and every
Exactly.
one.
But yeah, it would be nice to see this be fleshed out in more detail in upcoming sessions like this, and it'd be very nice for us to expose that to the community, so that they can not only leverage this as end users, I mean the business side of it, but also for people who can take this and build something with it, right? And that would be, I think, a very good, what you call, would be a nice to have in future sessions.
Yeah, no, absolutely. I'm working towards that. So definitely, as soon as I have that ready, we'll come back and share the details of it as well with the
Yeah,
community. Yeah.
looking forward to it. Looking forward to it.
Yep.
Absolutely. This was fantastic, Pradeep, and thank you so much for sharing. And viewers, please go ahead and like share your thoughts and what did you learn from this and what's your key takeaways. And as Pradeep said, he's got like a whole entire thing planned out in the future. to bring it out to the community, which is like a really nice thought to share with you all. So please again subscribe to our channel and like share this knowledge. And if you have some solutions as well, please feel free to share with us and we'll be happy to learn as well.
All right. So that's about it, guys. I think that's a wrap for us.
Yep.
And we'll see you in the next episode.
Thank you, everyone. See you
Thank
next
you.
time.
Bye-bye.
Bye now.